machine which we have selected for this project is a rotatory machine. Any machine which produce rotatory motion. So this is the machine which we have selected. Here we have this is the shaft which get rotated. This is the motor which is rotating this shaft, and in the shaft we have rotors, like we have discs. This is the disc which is used to produce the imbalance in this machine. Then we have sensor. This sensor will detect the vibrations produced in this shaft. Okay. So the sequence will be like that. First of all, the machine, the motor gets started. The rod is getting rotated, and so to test the vibrations, initially the vibrations are less. So to test the machine, we add some mass here. After adding some mass, some vibration will get produced in the machine. We record that vibration, okay, and through that vibration the machine get disturbed, and unbalanced force get produced in the machine. We record that unbalanced force also. So now I will explain you the data set which we have taken. Okay, so first of all, so the data set. So first we search on internet, we search on Kaggle, but the data set which we are planning, which we have in our mind, we could not find it anywhere. So what we have decided, we have decided to create our own database. The machine which I have shown you before, exactly the same machine we have in our college laboratory in mechanical department. We asked them to start the machine and get the readings for us. We got the raw data from our repository, from our laboratory in our college. In raw data we got the two readings. First is frequency and the second is amplitude. The frequency is the rate at which the machine motor is rotating. It is in RPM, revolution per minute. So we got readings for frequency for different frequencies. Then with the sensor which we have fitted on that machine, we got the amplitude. Amplitude is nothing but the vibration that rod is producing. So those two readings we got from them. Okay, those were raw readings. Now the challenge which we have is to create a data set from those two raw readings. So this is the procedure which we have followed. So we have frequency, as you can see we have frequency, and then we have to find out the unbalanced force. As you know, now then see, when we add the mass into that disc, an unbalanced force is produced in that rod, in that disc. That is centrifugal force, and the formula for the centrifugal force is mv square upon r. So we have the mass of that, the mass which we have added. We have the radius, we have the distance of that mass from the center of the disc. Then we have the angular velocity. Angular velocity is this. Okay. So we got all those things. We have calculated the unbalanced force. So in our data set we have those things now. We were having frequency, we are having amplitude. Then we calculated unbalanced force. And through and we have this mass also. This is the mass which we have added. So through this we prepared our data set. We trained through using this data set. Okay. After training, what we are providing in our input, we are providing the frequency and the amplitude, and we are predicting the output. What is the probable mass which we have added, which was added or which was subtracted from that machine, through which that vibrations are producing. And one more thing, it is predicting the severity. Severity is like how severe the problem is, whether it is negligible or very frequent. It is producing the number from 0 to 5. By increasing the number, we can see that the problem is severe. Okay, we have prepared a UI for this. I will show you the UI. So to prepare the UI, we have used Streamlit. Yes, this is our code. I will run it. Streamlit. See, This is our UI. We have kept it very simple and understanding. Like it will not get any issue. Like it will not confusing. Okay. Here I have to upload the file. In this file, I will upload the two readings, first is frequency and amplitude. I have uploaded this file. Now I will predict. See, as you can see, I have uploaded the readings for the frequency and the amplitude. For the frequency and amplitude, it has predicted the unbalanced force, it has predicted the mass, and it has predicted the severity. As you can see, for frequency 14 Hz and amplitude 0.01, the problem is very severe. So if this frequency and this amplitude occurs, then we should stop the use of this machine. See, this is giving a message that the machine need to be fixed. Okay. So then we have plotted some. We have done some data visualization. We have plotted some graph. This is the graph between the amplitude, frequency, and the mass. As you can see that, as the frequency included, as the amplitude increases, the mass also get increases. Then also we have graph data visualization between the mass and unbalanced force. This is the histogram which shows the relationship between the predicted and unpredicted predicted mass and frequency, and also unbalanced force and frequency. Then we have actual mass and predicted mass. The actual mass in our testing data set and the predicted mass which we got from our machine are very close. As you can see, the all are lying on single line. There are very few outliners in this. This shows the accuracy of our machine. The accuracy for our machine is 99.99, and we have used artificial neural network for to train our machine. From here I can download the entire data sheet, the output. As you can see, this is my output. Okay, this is the entire data sheet which we got from there. So that was our project. Thank you.